All right, we're live. Hey, everybody. Welcome to the CNCF meetup for the greater North Texas area. Today, we are going to be talking with Dr. Damian Igbe and Himanshu Patel, and we're going to take a look at how to manage your application deployment using Helm and the Helm operator. So, I don't know, before we get started, Himanshu, do you want to tell us a little bit about yourself, background, and then after that we'll kick it over to Damian. He can introduce himself and then dive right into his presentation.
Sure, thanks, Brent. So I have spoken on this meetup group a couple times before. I work at Aventive Technologies here in Dallas, and I do lead middleware engineering team there as well as DevOps practices. And we've been trying to establish the standards for containerization and Kubernetes across the board at Aventive. And I have been basically doing a lot of research work and kind of doing a lot of POCs, evaluations, and all that sort of things, trying to learn new thing every single day. And this meetup group, as well as few others, have been very helpful in our quest in embarking the journey. So that's it. I'm looking forward to be here today. And over to you, Damian.
All right. Good evening, everyone. And nice to see all of you here. I hope you're all keeping safe. So today I'll be giving you a presentation on managing your Kubernetes applications deployment with Helm and Operator. Hey guys, can you see my screen?
Not yet. Are you ready to share it out? I'll pop it up. So now we can see it.
Okay, you can do that.
Mm-hmm.
You can see now?
Yep, you're good to go.
All right. So I lost my other screen, but it should be good. All right, so that will be the topic of my presentation. Let me try to do the presentation right. I'm sure most of you here know me. So my name is Damian Igbe, and I'm a certified Kubernetes Administrator, and I have several years experience as a technical trainer. I'm the CTO of Cloud Technology Experts, and I love running. At least I try to do one marathon each year, but I'm not sure of this year because of the pandemic. And also, along with my colleague, I'm one of the organizers for this meetup. Okay, so the main objective. So this presentation, I just want to get you to be aware of the tools you have to deploy your applications onto Kubernetes platform. And even if it's just to get you to know those names, maybe one of the objectives to be achieved. Okay, and then once you know those tools, then I also want you to know the capabilities of these tools. What can they do for you? And then be able to differentiate also between these tools. So these are my humble aim for this presentation. The agenda is as follows. When I give a presentation, especially in meetups, I always assume that most of the people are new, because in reality, most of the time, most people are new. And I also realize that when people come to these presentations, sometimes they don't even have any knowledge of Kubernetes. So I don't just like to start presentation without getting everybody to be on speed. So I'll try to review the Kubernetes architecture. And that is also going to be very important for the presentation that I'm doing today, because the presentation is going to be about extending Kubernetes. And if you don't understand the architecture, then it won't be clear to you what it is that you are even trying to extend. So I'll start from the basics, show you the Kubernetes architecture, show you a deployment of a cluster that I have. What I use mostly for doing my stuff, I'll show you the cluster. And then I will show you how we manage applications in Kubernetes. And that's when we come to that, I'll talk about Helm, then talk about using your raw YAML files, and then moving on to using operators. And then I'll do a demo to show you some of the things I talk about. again, I don't like speaking in abstract. I like people to see what I'm talking about. So then I'll show you some of the things I'm talking about. And then after that, we'll conclude. If I finish my presentation early enough, Himansu might want to give a short presentation. But otherwise, then he's going to give a talk on another day. Okay, so let's get started. So this is the architecture of a Kubernetes cluster. As you can see here on the screen, we have what we call the control plane, and then we have the data plane. On the control plane, we have certain services which are running on the control plane. Everything starts from the Kube API server. So you can see all arrows point to the Kube API server. So Kube API server is a boss, if you like. Is the one that coordinates everything happening in your cluster. And then next to that, down here, we have this kube scheduler. Your kube scheduler, the job of the kube scheduler is very simple. The job is to say, maybe I have a microservice to run, and my microservice needs to occupy, my microservice has maybe 10 replicas. And for those 10 replicas, the scheduler will decide where to place those pods, as Kubernetes calls them. If you don't understand what a pod is, just take it to be a container. So then Kubernetes scheduler will try to put some of the pods here, distribute some other ones here, and put some other ones here. So as a matter of fact, it might decide to put 3 here, and 2 here, based on the scheduling it's trying to do, based on how many replicas you want to do. All right, so that's the job of the scheduler. Also, do understand that in reality, you have the capability to cheat on the kube scheduler. In other words, you can influence how the kube scheduler will do stuff. You can use stuff like node labels. With node labels, you can say, I want this specific pods to be on this node. You can also use stuff like affinity and anti-affinity to say, I want this pod to be close to this one or to be on this node, as the case might be. But just understand that you have the capability to influence how the scheduler will distribute your pods onto the different nodes that you have here. Then we move to the kube controller manager. For my today's presentation, the focus is going to be on the kube controller manager, because that is a component we're going to try to extend. All right, so I'll talk more about that throughout the presentation. And then you move to the cloud controller manager. The good thing with Kubernetes is that you can either use a managed service like EKS on AWS, or you can decide to actually deploy your own cluster on a cloud environment. And if you do, you are going to need a lot of resources, certain resources from the cloud provider. For example, when you create a service of type load balancer, you are going to need to contact your cloud provider to give you a load balancer. Also, if you decide to use a volume from your cloud provider as your backend storage for your pods or your microservice application, then you can also talk to the cloud provider to give you some volume. In the case of AWS, you can ask it to give you an EBS volume to get attached to your pod. So if you want those capabilities, you can deploy the Cloud Controller Manager that will help to speak to the Cloud API to give you all the resources that you need. If you don't deploy it on a cloud platform, then you won't need a Cloud Controller Manager. We have a tool called KOPS, K-O-P-S, which is Kubernetes Operator. If you use it to deploy your cluster on a cloud environment, that will automatically connect your cluster to your cloud provider, and then your cluster can speak to the API of the cloud provider. So that is what that component there is doing. Then the last one here is called etcd. So this is basically your data store. This is where everything that you configure on your cluster is going to get stored on. And as you can imagine, if you lose etcd server, you lose everything. If you lose the etcd instance or component, then your cluster won't have anything stored. You won't remember the pods you are creating, the scheduler, the replica sets, the deployment objects, whatever it is you create, you lose count of it. So you can imagine that your etcd server has to be really, really reliable. So often you want to make sure you configure it to be in a kind of a multi-cluster or a HA fashion so that you can have redundancy and failover capabilities. So on the control plane, these are all the components that we have. Then let's move to the data plane. On the data plane, you have your nodes. And here we have just 3 nodes. And you can replicate this to as many numbers as you want. If your cluster has, if you have the resources to spin up to, say, 5,000 nodes in your cluster, you can have up to that. In fact, clusters have been benchmarked for up to 5,000 nodes. But you can start as little as 1, or you can start as many as 5,000 nodes. So basically, this is all scalable. At the same time, you can decide. Sorry, I wanted to say that on each of the nodes, the architecture of each node is going to be the same. So basically, you're going to replicate what you have here across all your nodes. So on each one of the nodes, you have something called a kubelet. So as you can see here, the kubelet is the kube API agent on every worker node. You can see here from the arrow, this talks directly to the kubelet on every worker node. Okay, so if you wanted to provision a pod, for example, the request will come from the API server to the kubelet, and the kubelet will talk to the Docker runtime. And you don't see the Docker runtime on this node, but in reality, they have to be a container runtime. In this case, if you're using Docker, then you need to have Docker on every node. That is not shown here. So that is the kubelet. Then here you also see another component called the kubeproxy. The kubeproxy is responsible for the low-level kind of nitty-gritty traffic flows, okay? How traffic actually moves from the load balancer to the respective pods. And in Kubernetes, the load balancer is called a service object. So without the kubeproxy, then the service object is not going to be able to perform its function. And actually, when you deploy your kubeproxy, it can exist in several modes. You can either use it in the user mode, or you can use it with IP tables, which uses the Linux kernel net filter, or you can use IPVS. Currently, IPVS is the default because that is the most robust feature for production environments. So basically, when the kubeproxy set up a lot of IP table rules, and on your node, if you check your IP tables, you see that each time you create a service object, you're going to see a lot of IP table rules being added to aid the working of the service object. Okay, so that is what the architecture of Kubernetes looks like. You have your control plane, and then you have your worker, the data plane. And the control plane consists of the master nodes, and then your data plane is where your workload actually exists. Take note of this, that anything you do to manage your cluster is going to be on the control plane. So you don't have you don't have much to do with the worker nodes, because the Kubernetes control node plane takes care of everything that needs to happen on the worker nodes. So it will be the one that will distribute all the traffic to the worker nodes when the need arises. Okay, so now I hope everyone understands the architecture. If you understand that before, then this is a refresher for you, and that will be important for what we're going to be talking about.
Hey,
and
Damian, sorry to interrupt.
Right.
But one thing I think could help, you're in. It looks like you're in presenter view for PowerPoint, and I think the diagrams would be larger and easier to read if you were in whatever that other view is, where it only shows you the slide.
Okay. Let me play a little bit with it and see.
Okay.
If that makes, is that better?
Yes. So
okay.
let's just hover on this real quick, just so people can kind of see the flow and the arrows and the descriptions, and then we can go on to the next slide, and it should be quite legible.
Cool.
And while we're paused, let's just remind everyone there's a chat function that is in the YouTube live stream, and we're watching for questions coming in. So definitely throw questions into chat as you think of them, and we'll try and address them and get them answered.
Okay, so do you want to say something, or I should continue?
Oh, go ahead, continue.
All right. Did you say that I should expatiate a little bit more on the architecture?
No. I think I just wanted it to be visible
Okay.
for a few seconds, so that anyone that was having trouble seeing it would now be able to see it. And yeah,
okay.
we did just get a comment. Karthik said, "Much better now."
Okay. All right. That's good to hear. All right, sounds good. So that is the architecture, and that sets the stage for what I'm going to be talking about. I actually mentioned this, the service object earlier when I talk about the kube proxy, and I say that the kube proxy has to work with another service object in Kubernetes called, well, has to work with another object called the service object. So, and I also mentioned that the service object is like a load balancer. So this is just illustrating how the service object works, okay? If you haven't been playing a lot with Kubernetes, this will probably not make a lot of sense, but I'm sure that later on when you start playing with it, this might help you. So basically with the service object, you have to use this as a load balancer, and then the load balancer points to the respective back-end pods. In this case, we call them the endpoints. And this is not different from how a load balancer works in reality. Even if it's a physical load balancer like F5 or a virtual one like ELB or an Amazon cloud, it is the same thing. But the point I want to stress here is that the kube proxy is the one that has to set up all the rules to enable the communication between the service object and these endpoints. And that involves setting up a lot of IP table rules on the Linux kernel. All right, so now that we understand a Kubernetes cluster and what it looks like, again, for those of you who are completely new to Kubernetes, I'm going to log on to my cluster, and I'll show you those components that I just talked about. So I'm already logged in here on my Kubernetes cluster, and I'm just going to clear the screen. So to interact with Kubernetes, you need to use a command called kubectl. And I'll talk, so you can use kubectl mostly, or you can use the dashboard. And I should be able to show you my dashboard as well. So basically, there's a lot of options for kubectl, but the ones you need the most, you're always going to need kubectl git nodes. So this is going to show us how many nodes we have on this cluster. So this is showing us that we have one master, one control node for the one master for the control plane, and then we have 4 nodes for the for the data plane. Okay, so 1 for the master, 4 for the nodes. So now we see the number of nodes. So I can also show you the components that we just talked about. So if I do kubectl git pods -n kube system, that will show us the components I just talked about. You see here, this is your API server. This is your controller manager that I'll be talking more about today. This is your kube proxy, which is represented on every node. So basically, every node has a kube proxy, and that has to get represented when you do this command. And then here we have our kube scheduler. Okay, this is my CNI, container network interface, and this one is using Weave. Okay, so if you don't understand the CNI, again, that's another big topic, but that helps with your networking configurations on your cluster. Okay, then we have here the etcd server, which is going to store our data. And this is an add-on called Core DNS. It's an add-on, but it's very useful for your service discovery. So it's good to have that on your cluster. And yeah, that's all the components that we talked about earlier. So you've seen how the cluster looks like, and you see how to navigate a little bit to get some of these services that are running on your cluster. You notice here that when I did kubectl, I had to put -n kube system, which means I'm pointing it to that namespace. If I don't point it to that namespace, if I remove that, it's going to go on the default namespace. And all the stuff I have on my default namespace are going to come up at this point. Okay, so that is our Kubernetes cluster. So let's go back and continue with the cluster, with the presentation. So let me start again to present from here. Let's switch back. Okay, so when it comes to managing applications on your Kubernetes environment, you can do it in traditional way, or you can do it, through what I'll call maybe the modern way. Okay, and these are just my terms. So we can use Kubernetes kubectl, which I just showed you, or we can use the dashboard, the Kubernetes dashboard. I have both of them to be able to show you. And then later on, once I finish showing you how this works, then we can see how these ones work. Explain the differences between them. And that really is the aim of the presentation. So again, for those of you who are kind of completely new to Kubernetes, let me show you the kubectl and the dashboard, just to deploy a very simple application. So I'll go back here, and in Kubernetes, before you actually use the kubectl command, you have to have a manifest file, or you can run it from the CLI. Okay, I mean, you can either create your objects without having to create a declarative manifest file, or you can first create a manifest file where you specify your desired state. In your manifest file, you tell the system, the Kubernetes system, this is how I want my object to look like. And Kubernetes will go ahead to enforce what you said you like your object to look like. So let me show you a very simple manifest file, which is going to create a pod. So let's do my vim, my pod, the YAML. So here's a simple YAML file. This is written in YAML syntax. All Kubernetes files, manifest files look the same. I mean, they follow the same syntax. You're always going to have the version, then the kind, and the metadata. Okay, depending on the object, if you are dealing with a replica set, you have to change that replica set. If you are dealing with a deployment object, you have to change that to a deployment object. However, once you change that kind, every other thing here could differ. Every other thing going down could change. For this one, we're dealing with a pod. And really, if you want to see all the parameters, all the properties of a pod, you need to go to the Kubernetes reference, the API reference, and you see them there. So, but this is just to show you how to deploy a simple application or a container. So here, we are going to use this image. That's the image we're going to use. Basically, this is an Nginx image, and the version is called Staple Alpine, and we're going to name it Nginx. And this Nginx is going to be running on port 80. So let me come out of this, and then to create it, I just simply do kubectl create -f mypod.yaml, and it says my pod has been created. Now, this is going to get created in the default namespace because I did not specify where it should go. If I want, I could do kubectl get namespace, and I have a namespace here called meetup. If I do kubectl get pods -n meetup, there's nothing in there. So I should rather put this object into my meetup namespace. So I can do
yeah, it's just -n.
Yeah.
Perfect.
So now I got the object created. Now, if I want to see the object on that namespace, I need to do kubectl get pods -n meetup. And it's showing me that the pod is pending. Let's check it again. But if it continues to be pending, it probably means I don't have enough resources on my node, on my worker nodes. And if I don't, that will be trouble for the demo I want to do. But let's do kubectl describe pod, and let's call it my pod minus namespace meetup. Okay, so it's saying that no node is available. I believe that is because of the operator I was trying to deploy earlier. Okay, so I might as well, let me delete the operator, and then I'll put it back again when I do the demo. So to delete the demo, the operator, I need to do Helm. I need to do Helm list because I deployed it with Helm. Okay, so I'm going to do Helm delete. I haven't come to Helm yet, but now I have a need to use it. Let me just remove the Prometheus operator.
While you're doing that, let me address a couple of the questions from chat. So one of the questions is, can we get a copy of the slide deck? And I'm guessing that, Damian, you're willing to share those slides out after, we could just probably send that out through the meetup.
Yeah, definitely. Actually, I don't have a lot of slides, but the good thing is it's all recorded. So
exactly.
you can go back to the YouTube channel, and you can watch this over and over again. But the slides I have, I can also share them.
Yep. And then another question from Funnybone, who's, hi, this is Amal. Is there any configuration to set or change the default size limit for Kubernetes resources like config map? When I first think about that question, I'm not aware of any size limits unless you set them. Damian, are there size limits? Like if you launch a container in a pod, is it restricted in any way if you don't actually set any restrictions?
Yeah, definitely.
Are there default restrictions?
So he's probably talking about quality of service. So when you create your, let me see, I might be able to find an example. When you create your pod, you need to specify the resource limit. You need to tell it how much RAM and CPU is going to use. You have the capability to specify those resources. If you don't specify anything, then Kubernetes will allow the pod to use as much as it wants to. In fact, if it wants to use everything on your cluster, it can. So that is not good because when it comes to quality of service, what Kubernetes does, if Kubernetes needs some resources, the people that don't have the pods, I'm calling them people, the pods that don't have any restriction, those are the first that Kubernetes will start to kill. So for those ones that behave that says, okay, I need just 2 CPU, 2 GB of RAM, those ones, the Kubernetes leaves them until maybe it's really, really hard priced, then it will do something about them. If you look at my, when I do kubectl get pods here on my default namespace, you see that I have a lot of pods. Some of them are getting evicted. Usually this happens when some of these pods that are being evicted don't have any resource limit. And so Kubernetes is trying to do some quality of service, maybe because you need to also run some other pods which are of high priority for one reason or the other, and then to start killing off those people that are not behaving, those people that just say, okay, I can use all the resources in the system. So yeah, definitely you can specify a resource limit for your objects.
Gotcha. And Manish, and hopefully I'm saying your name correctly, says you can use NS quota and cluster quota also. So that might be a way to set sort of a, depending on your boundary, I guess, that you care about, you can set a quota for either the cluster boundary or the namespace boundary. Good
That's
call.
Correct. Yeah. That is very important because when you have several teams working on a project, you don't want one team to consume all the resources. So then usually projects work on namespaces basis. So project A can work on namespace A, project B can work on namespace B. If you don't set a limit for namespace A, again, it can use all the resources. So a lot of time, the administrator would like to restrict how much project A can use and how much project B can use as well. So yes, you can set them at the namespace level, or even when you set them at namespace level, you still have to, it's a good practice to still tell the individual pods how much resources they can use.
Totally agree.
Yeah. Okay, so let me delete my Prometheus operator, which I wanted to keep, but I think I can put it back. So let me do Helm list first of all to see the names. Then I'm going to do Helm delete and put this there. So once this gets deleted, hopefully I should get a lot of space.
Cool. And while that's deleting, Solomon says, but how do you determine or know the right resource sizes? And I chuckle at that because that's, the $1 million question. Every application, every microservice, every container is going to benefit or waste resources depending on how you size it and how it behaves. So it's really highly specific. However, there is a project called the Vertical Pod Autoscaler that if you wanted to bring some level of automation, you could actually have that size your pods for you, but you have to be willing to accept that on occasion, a pod might get killed and brought back alive, with more resources devoted to it. So if you are just trying to dial in and set the right constraints for the sake of having constraints, you wouldn't want to use the vertical pod autoscaler. But if you wanted to, size your pod correctly for scaling purposes or performance purposes, then the vertical pod autoscaler could probably help with that.
Okay, yes, that's a good contribution. So what I observe is that some of the practices that the cloud providers like AWS tend to emphasize are also true when you come to platforms like Kubernetes. For example, one of the good things with the cloud is that you don't have to really gauge the size of your workload in the cloud. Why? Because you have something called autoscaler. The autoscaling service will help you to determine how much resources is needed. So if you need 1,000 virtual machines, for example, your ELB, your autoscaling mechanism should be able to help you do that. So the size you start with a lot of time doesn't really make a difference because the system will help you adjust it anyway. So it's the same thing that Brent just talked about. If you are using Kubernetes, it has features called the horizontal pod autoscaler (HPA), and also it has a vertical pod autoscaler. But in the cloud, we don't do much of vertical scaling, so the horizontal pod autoscaler (HPA) is the one that you want to use a lot of time. And so, if you don't know the exact size of your application, if you don't know the exact size of requirement for your application, you can start out with something and then try to put the horizontal pod autoscaler on top of it, and then it should take care of it. At the same time, if you're able to gauge how much your resources you need, maybe you have an idea of your application, how it behaves and stuff like that. If you've been running it on-prem and you already have some metrics, maybe because you've been monitoring that application and you can have some ideas, then by all means you can bring those ideas on board and use it in planning your application.
Yeah, and there's some conversation in the chat about how do you find what the limit should be, and one of the suggestions that was made was start with something high that you never expect to hit, and I actually have done the opposite. I start with something low, not trying to get the pod killed or anything, but if you start with something low and you see the performance, or if your application runs out of memory or something to that effect, then you can graduate that up a little bit, and then incrementally increase the resources until you don't crash anymore. And that's how you can know, without being a developer, that's how you can know that this is probably the right level or close enough to the right level. It's very much the same that you would do if you were trying to size an instance to run your application. You could start with a T2 micro, and if it doesn't work, then go bigger. And if that doesn't work, then go bigger, and so on and so forth.
Yeah, and to add to that as well, again, because I do a lot of AWS, so they say that when you move your application to the cloud, to start with, again, like I said before, don't be so concerned. Maybe the part I didn't add was, now start to monitor your application. Use something like CloudWatch to start monitoring your application. Start getting those metrics. As you start getting those metrics, sooner than later, you're going to know whether your application is more CPU intensive or more RAM intensive, memory intensive. Then based on the metrics that you get from CloudWatch, you can do that for a week or thereabout. And also AWS has something called the Trusted Advisor. The Trusted Advisor can actually advise you on how you are doing on your resource utilization. Then from there, you can say, okay, I think I need to increase the RAM, or I think I need to increase the CPU. And that gives you a very good starting point because, as you know, a lot of people use resources or EC2 instances that they don't really actually need, because maybe your application needs just one vCPU, but you're using a 5 vCPU or something on that particular application, which means you're wasting a lot of resources. But by bringing in some intelligence, some monitoring to give you some informed decision about what is going on, then you're in a very good position to not spend too much, not spend way too much above what you should be spending.
Yeah, and Manish actually kind of agrees with you there. He said, also it's useful to know whatever the language is that the application is written in. A lot of times, and his example was Node.js, that's a single-threaded language. So you can know, in the case of Node.js, that unless it's going to spawn additional processes, it's going to only benefit from having one core. There's no reason to try and give it additional resources in the form of CPUs because it's not going to use them. And you can get that kind of insight if you don't know that Node.js behaves that way by running the application and observing the resource utilization. And you would see that even if you gave it 8 cores, it's only utilizing one of those at any given moment. So just observe it over time, and you'll start to learn that, hey, this is single-threaded. It only needs 1 core. It's only using, X amount of RAM. That's when I'm going to set my limits to.
Yeah, very good. All right, so I managed to delete Prometheus. So now I have some spaces, and now you see my pod is running immediately. And that's one thing to take note of, because I've played with this quite a bit, so I know that a lot of time my pods will go into pending. And when you describe them as I did before, it was saying, hey, you don't have enough space. And so I know that I have to free up some space. And so to do that, I use a command describe. So it's a very good command to use a lot of time to show you what is going on in your pod. So now if I describe that, it's going to be good. You see, it told me now that it's created a container and I'm good to go. But before, it was telling me what was happening. That despite the fact that I have 5 nodes on my cluster, none of them is suitable to put the pod because they don't have enough resources to host it. And if you look at the quality of service I was talking about, that is what you have here. It's using what they call the best effort. So best effort is pretty much like saying you haven't given any resources limit to your pod. And because of that, I'm going to try and use if as much as I want. Because you can see down here, I don't have any resource restrictions. But ordinarily, if I wanted to give it a certain quota, I can put it there. Anyhow, my pod is now running, as you see it there. And if I go to my dashboard, I have my dashboard here. I kind of made it quite small so it can fit into the screen. But this is the Kubernetes dashboard, and I can see that is my pod. It's giving me a very good statistics, or it shows all green, which means everything is good in my pod. It shows here that that's the name of the pod. It shows the level. It shows the node. It tells me where it's running on. And I always like to know where my pod is running on, because if I needed to do some troubleshooting, I might need to go to that particular node. Remember that pods run on a particular node, on the worker node. So if I do kubectl nodes -o wide, that will give me also which node my pod is running on. So it's showing me for this one, I need to make it smaller, so I can have it all in one display. It's showing me that my pod, this one here, is running on node 01, which is the same thing that I'm seeing here. So when I come here to my dashboard, I have to come here first to my namespace. So it's very important to understand the concept of namespace, because everything in Kubernetes is based on namespaces. For example, I told you earlier, when I created that pod, if I didn't specify which namespace this should go, it would go on the default. But because I specified I wanted it to go to meetup, so it went there. So when I came here, I had to immediately find my meetup namespace and do it there. But if I want to see all my namespaces, I might as well click on that, and then I'll see all the pods in all the namespaces that I have available. So understanding the namespaces is important. But the point I want to make here really is to show you that what I did from the CLI, that I created my pod, I can equally do it from the dashboard, which means if you don't want to use the kubectl command, you can always come here to the dashboard if you have it deployed, and you can do stuff from here as well. Okay, so let's try and create another pod. Maybe let me delete this one first.
Damian, so just a quick question.
Yeah.
What is that control plane or a dashboard that you're using?
That is the Kubernetes dashboard.
Okay, so it's k@dash. Is that what it is?
Kubernetes dashboard. So you can install it. You can see it here.
Okay.
Yeah, you can. Now I'm logging in with a token. You need to set it up properly, and then you can use it to manage your Kubernetes environment. Otherwise,
can you manage multiple clusters with it, or it's one per cluster?
No, this is going to be one per cluster.
Okay.
Yeah. At least as far as I've used it.
Yeah.
But then, go on.
I was just saying, yes, it is one. You install it in the cluster, and it will only manage the cluster that it's a part of. And by the way, EKS Workshop has some instructions on installing the Kubernetes dashboard, and I'm going to paste the URL for that in the chat.
Okay, so I'm going to go ahead and delete. See, this is my default namespace. So all the pods are my default namespace. If I start scrolling down, I'll see all of them. And this is quite handy. I like the dashboard. A lot of time you don't get a lot from dashboard, but this is good. If you come here to your CPU usage, it's actually showing you how much CPU each one of this pod is using. It's showing you how much RAM each one of this pod is using. And it's telling you also how long this has been up and running. It's showing the status. It's showing the node where they're running. And labels. Every pod, where pods usually have labels, and they are very useful for certain objects. For example, the service objects needs the labels to be able to do what it needs to do. Then we have replica sets. I'm going to show you what replica sets do because they're important to my presentation tonight. And then we see a lot of objects. These are all Kubernetes objects. And this is also going to be relevant when we talk about custom resource definitions, because all these objects we see here, these are all Kubernetes native. These were born with Kubernetes. But you can also add your own objects. You can create your own object. You can extend Kubernetes with your own objects. And that is what we talk about, what we call the custom resource definitions. And when we go there, that is where we're going to tie that with how you also create your operators. Okay, so first, I'm showing you that you can manage your cluster either from the dashboard or from the CLI. Whichever one you prefer, both of them are capable. So I created my cluster, my pod here. Let me delete the pod that I created, created earlier. So to do that, I'm going to do kubectl delete pod, my pod minus namespace meter. And then this should get deleted. So if I go back here, I won't see that anymore. But I can still use that YAML file. I can cut my pod.yaml, and I'm going to take all this file here, copy it, then I'm going to come here to my dashboard, and then I can come here. It's hidden, but it does a lot of work. So click on that. Once you click on that, you have 3 ways you can create your objects. You can either put put your YAML file right here. Since I have my YAML file, I can do that. Or I can say create from file, and I can actually go and browse for that file that I just copied. You can go to my system and browse for that, and I can bring it on board. So whichever one you prefer is up to you. Or this is the easiest. You don't even have to write your YAML file. Just give it a name, and then give it the image name. And then once you tell it how many pods you want, you see this will become highlighted. So let's say my pod. And let's say the container image is Nginx. This will give me the latest Nginx. So now if I say deploy, that will go ahead and create it for me. So I don't even need to know how to write YAML files these days. In any case, this is the one I want to create. This is the one I want to show you because I already have the file here. So once I do that, I'm just going to say upload. Okay, that one already exists. So let me change to my namespace, which is the meetup namespace. And then I should be able to create it there. Okay, so now it's creating. See, it's going to change to green, which means everything is good. All right, so yeah. So now it shows me how much CPU is using, RAM, and it's going to give me all that specification. So the underlying factor here is you need to have a YAML file, well, especially if you're doing it from the CLI, or if you're doing it from here, you can fill in your forms. But actually, if you're doing it from here, sometimes what you could do is to use a command called kubectl, edit, and I can say pod, my pod. I have my pod here, so let me edit this. So this is actually everything. This is how Kubernetes recognizes this object I just created. This is how it recognizes it. So sometimes if you don't even know how to create YAML files, you can come here, generate it, then edit out all the stuff you don't need. Because in here, you're going to see a lot of stuff you don't need. Okay, so you can edit them out to make it very small. If you remember, the actual YAML file was very, very tiny, but here, Kubernetes has made it so large because there are a lot of default, which I did not put, and it just says, okay, since you didn't specify that, this is what I'm going to give you. And that is what I was talking about with the default quality of service. If you don't tell the system, use this type of resources, then it's going to say, all right, since you didn't specify, I'm just going to give you what you want. But like I said, that is no good for production applications.
And I would even say you want to stick with defaults as much as possible, and then only override them when you know better. Like if the system is able to make a good enough decision, it's valuable to let it make that decision for you, because as software improves over the versions and stuff like that, then those improvements can, those defaults can be adjusted along with the improvements. But if you start to bake in every single decision and you take that decision making away from the system, then you end up having to go back and sort of reevaluate if that's still the best way to run this, across each and every version as it rolls out. So provide it the things that it can't know ahead of time, like where the image is, perhaps how many you want running, and stuff like that. But let it decide, how to assign IPs and all of those other things that you don't have to fill in. So we did have, you were filling in some YAML, and Vara asked, how do we generally manage multi-cluster in different regions, like creating namespaces and deploying pods simultaneously in both regions? And then Edward actually beat me to the answer. He said for multi-region clusters, that would be in the domain of your CD pipeline. So you'd want to look into something like Argo CD. And I definitely prefer Argo CD and Flux, those are both, they fall into the category of GitOps, or at least Argo can do GitOps, and Flux definitely is, centered around GitOps. But one of the things that's cool is you can take what Damian was just showing you about YAML, and you can commit it to a repo, and then you can have all of your clusters, sort of paying attention to that repo and downloading the YAML anytime there's a change and applying that change locally. So that's how I manage multi clusters, especially, and then it doesn't even matter if they're across different regions or not. That's definitely an advanced topic. It's beyond the scope of tonight's talk,
Yep.
but
Yep.
that's probably the best answer today.
Yeah.
Yeah, and I think just to add to what Brett said, unfortunately, there is no open source control plane exists that lets you support multiple clusters. If you're looking for a control plane solution to support multiple clusters management, then you have to basically consider something commercial. That's that's kind of pretty unfortunate thing, but I agree. I mean, I wish there was a support to manage multiple clusters by open source control plane. It doesn't exist.
Okay, so this is all in the areas of Kubernetes Federation, which is becoming stable, and people are now thinking a lot about multi-cluster, where you want to have your cloud even spread across different cloud providers for different reasons that you may have. So, like Brent said, this is definitely above today's presentation, but we keep giving presentations. Actually, we're going to make a suggestion later on. If you have a request for kind of things you'd like to hear in these meetups, by all means, send us an email. I wanted to send the email out, but I haven't done that yet. Let us know the kind of things you'd like to hear about in these meetups, and then we'll try to get the experts to come and talk more on those kind of topics. All right, so let's move on. So now we see how to at least create a pod from the CLI and from your dashboard, and it's up to you to decide which one you prefer. Okay, so this is good. This is how things have been done in a traditional way, but sooner than later you're going to want to do something more effectively. And the way I like to, the way I like to see this is that if you look at Kubernetes, people now call it the OS of the cloud, the operating system of the cloud. And so try to compare Kubernetes to something like CentOS or Red Hat or Ubuntu, the operating system. And I've been around. I started using Linux since around 1998. 98, I started using Linux, and that was when Linux was actually becoming, a little bit. People are beginning to hear about it, not mainstream yet. And I knew that then to do things were very hard. And so those were the days where there wasn't any particular package management like YAML and APT, YAML for Red Hat and APT Gate or APT for Ubuntu and the rest of them. So the way we're doing things here is like those days where you are doing things the hard way in managing your cluster. And so sooner than later, someone is going to say, hey, this is not scalable. This is very difficult. I'm not going to continue doing this. Let's find a better way to do that. And so back in 2015, I believe, Helm started. It started as a project like being the package manager for Kubernetes. Since this is the operating system of the cloud, and since the operating systems need to have a package management software, why don't we create one for Kubernetes? And that is what Helm is. So in a nutshell, if you haven't used Helm before, if you have used Ubuntu and you've used apt-get, or you've used YAML on CentOS or Red Hat or Fedora or any of those operating systems, then that is Helm for you. And you can see that that is a lot better than using this. At least you can see that with Helm, you don't have to manually manage your YAML files, even if you don't know how to create them. Once someone has already created that into a package, in Helm, they call them Helm charts. So someone already created the Helm charts. All you have to do is use Helm install to install it. And you've already seen me do that. I have Helm installed here, and if I do Helm list, I'm going to see just one for the etcd operator, which is what I'm going to use for showing you some of the features of an operator. So if I wanted to delete it, and I could probably do that because I'm going to delete it and create a new one for you to see, I can just do Helm delete, like you saw me do for the Prometheus. I can say Helm delete, put this there, and boom, it's gone. So this is your YAML. This is your APT. And since Kubernetes is an operating system, so it makes sense to have something for it. It makes your life very, very easy. So if you want to do things like upgrade, you can do upgrade. If you want to, upgrade, do some patches, you can do all that kind of stuff. You can install your applications. You can delete your applications. If someone develop a microservice in your organization and they would like to make it available for people all over the world, they can package it as a Helm chart and send it to a Helm repo. And if you look at here, if I do Helm repo list, you see my repositories. So if you wanted to install some application which is not already on the repo, just add it. It's the same thing you do with YAML. If you want to install an application which is not available on your default repo, just add a repo that has it, and then you can install. If you want to update your applications, just do Helm update. And that will, that's Helm repo update. And that will update all your repositories and make them up to date. And now you're ready to start to install your charts. So remember, they call them charts, Helm charts, and those get packaged appropriately. So if you go to Helm, Helm has a website which is called Helm. And if you go in there, you can see it has a very good getting started page, helm.sh. You can go in there and you can get going with Helm very, very easily because it's quite easy to install. On the home page itself, gives a document. Okay. So if you're managing your cluster, I would say move away from just your regular YAML files. At least use Helm to help you manage your applications. That will make your life a lot easier. And then you need to learn to create Helm charts as well. That would be the next stage to go, which is always the case. When you use Red Hat, at some point, you need to learn how to create .rpm files. You have an application, you package it into RPM. And I've done a lot of those in the past as well. So Helm makes a lot of sense to me. Okay, so I don't know if anybody has any question on that. What I want to also emphasize is that now that I'm going to talk about the operator is going to state what it's doing at this point, okay, before we start to look at more features of what it's actually trying to do. So compared to Helm, you can also have operator to help you install your applications. And if any of you have been around in this meetup for the past, 2 years, I think I gave a presentation on how to deploy Prometheus with Helm operator. That was about 2 years ago. So what I'm trying to say is that as at then, operator was very, very new. It started around 2016. So now you can say about 4 years. But like anything, when it starts, it has to gradually make its way up. When people start to hear about the service and what the capabilities are and what it can do for you. So I would say operator has been gaining a lot of weight in recent times, and for the right reasons. And you're going to see the right reasons. And so then for me, the major confusion was, we have Helm, why do we still need operator? So that wasn't clear until I stayed on it, and now I know what Helm can do and what operator can do. And so those are some of the things I want to make you to realize that they are different. They can complement each other. You don't have to use one or the other. A lot of times, you probably need to use both of them together. However, I've seen that in a whole lot of stateless application deployment, Helm does a very good job. And you may not have to use a stateful the operator. However, if you have a need to use a stateful application in Kubernetes, then that is where the operator shines. Operator was designed to help you manage things like databases, etcd server, MongoDB, RabbitMQ, any database, any stateful application. To manage them, Operator will help you do that. And again, if you follow how Kubernetes has been evolving, when Docker started, it was mostly for stateless applications. Create these applications, don't store any state in them, scale them up and down as much as you want. If you need to get rid of them, then scale them down. No need to share any state, no need to store any information. But sooner than later, people realize that, wow, containers are really fantastic. Who would like to run stateful applications on them as well? But that was, in a way, was difficult because stateful need to store data. But Kubernetes or container wasn't designed for that. But over the years, they've managed to make it work very well. So now we have stateful sets. No, sorry. Stateful sets. But now they used to call them pet sets, but now they're called stateful sets, which are becoming a dominant feature in Kubernetes. So to manage them, that is where you need the operator. So take the operator to be like you trying to deposit the experience of a DBA. A DBA who knows how to back up a database, stand up a cluster, upgrade it, scale it, anything you need to do on a database, performance optimizations, anything you need to do. Take those years of experience of the operator, of the DBA, and put it inside the software, which leads us to automation. So operator is all about automating your environment. It's about day 2 operations. Day 1, you install the database. What happens in day 2? How about all the hard stuff you need to do? How about the, like I mentioned, and I have another slide here to mention some of those things that you need to do. Okay. I was in the wrong place. Okay, so all this day 2 operation, failures and healing, patches, upgrades, scaling, reconfigure, backups. So operator is like you take all this knowledge and you give it to your applications. Then you enable your applications to be able to do what it needs to do, right? So that is introduction. Before we actually understand operators, we need to understand the control, the control manager that we saw earlier on the architecture. We need to understand what is a controller. So that is what I'm going to show you before I come to give you a demo on operator, and then that will probably be leading to rounding up at some point. So I'm right here on my cluster. Let's try to understand what an operator is. Let's try to understand what a control object is. So Kubernetes has this concept of a controller. And basically, I put it in a diagram here. Let me present this so I don't go down, up and down in the slide. Okay, let me switch. So basically, this is what a control loop is. A control loop simply has a desired state, and then it has to compare the desired state with the current state. Take this example, if you're not familiar with the concept of control loops, to your home. In your home, you have an air conditioner. You set a thermostat. You want your temperature to be maybe 30 degrees, like Brent, because he likes it really cold. So you want it to be 30 degrees. And then what does your thermostat do? It continuously monitors the temperature of your house. As soon as it goes below, it brings it to 30. If it happens to go above, it brings it down to 30. So that is what we have here. So 30 degrees, in this case, is your desired state. Whatever you have here, which is current, is your current state. But your thermostat will try to bring it back to what you want. So this is exactly what Kubernetes does. There are certain objects that are called the control objects. And deployment is one of them, deployment objects, and replica set object, and daemon set. But the one I'll talk about mostly today is mostly just maybe replica set and deployment. So to see how those work, let me show you. All right, so I'm here on my cluster. I'm going to delete the pod I created earliar. Kubectl delete pod, my pod. I'm going to delete the one that was on my default namespace, not the one on the meetup namespace. So this pod has been deleted. It's going to be deleted. So let's wait for it to get deleted. And now if I do kubectl get pod, pods to grab my pod, this pod is nowhere to be found. It's gone forever. But how about if this were your microservice application? You want this pod to be monitored. If anything happens, you want it to be able to bring back your microservice. You want it to constantly monitor it and bring it back to your desired state. Maybe your desired state is 3 replicas, but the current state is 0, but nothing is happening. Why? Because a pod object is not a controller object. So let's use an example of a controller object. An example of a controller object, which I mentioned, is a deployment and a replica set. So let's just see this one here called vote deployment. So this is a deployment object. And when I finish this, I'll show you all the Kubernetes objects. So as you can see here, this is of a kind deployment. And basically, if you're not very familiar with Kubernetes objects, everything from here up is about deployment object. Everything from here down is about the pod. If I remove everything here and I change that kind, if I delete all that and I change the kind to pod, I'll have a pod object running. I'll probably change the version as well to version 1. Then I have a pod. But when you have a deployment, it's actually going to be controlling everything that you have here, which essentially is your pod. Because you can see the section here for containers. This is the image of the application we're trying to deploy. So when we deploy this application, it's going to be controlled by the deployment object, and the replicas are going to be 3. That is our desired state. If this varies, if this goes to maybe 2 or 5 or whatever, my deployment object will bring it back. So let's see how that happens.
Sorry, while you're typing, let me see if I understand you correctly.
Mm-hmm.
So I could use kube control and I could build a pod object.
Mm-hmm.
And then if I delete it, it stays deleted because pod is not part of a control loop.
That's correct. Mm-hmm.
If I use kube control and I build a deployment object that includes a pod,
mm-hmm.
and then I happen to delete the pod, that deployment object is a control loop, and so it's just going to sit there constantly checking to see, do I have my pod? And when it gets deleted, then the control loop comes back and like fixes that and brings up a new one to replace it. Do I have that right?
Exactly.
Sweet.
You put it the right way. And by the way, every deployment object has to control a pod. Deployment objects are there to manage the pod.
Yep.
Just to clarify.
Yep.
Mm-hmm.
So we did have a question, and I think you might actually, this might be ahead of what you plan to talk about,
mm-hmm.
but and just say so if you're going to get to it. But it's from Funny Bone. He says, as using Helm, we are deploying and updating a complete application in Go, I think is what he meant. But what if I have to change a single resource and I don't want to touch any other resources in the app? And I think what he's getting at is if you're using Helm to deploy, a collection of things all together, and you want to only update one of them, will Helm cycle and replace everything on every deployment, or will it only replace the things that have changed? And my experience is that it only replaces the things that have changed. So in other words, if you have a sidecar, your front end, and a persistent volume claim, and you only change the front end, the sidecar doesn't change, the persistent volume claim doesn't change. So those two things don't go away every time you do a Helm upgrade. They don't get cycled out, they don't get changed, but the front end does. So that's my understanding. What's your experience with that, Damian?
Yeah, I'm looking at it from this perspective. So we need to understand exactly what it means by making a change, because if you deploy your application with Helm, maybe the Helm has deployed some pods, some deployment objects, some service objects, like some RBAC, cluster rule, cluster, row binding, whatever. You can individually edit any of those. You know that command I showed you earlier when you do kubectl edit? You can edit a pod that was deployed by that Helm and make a change to that pod, and that you don't have to restart. That doesn't touch Helm. If you were to create another deployment of Helm, then it will probably delete this one because it's not part of what Helm is, because you have to delete the existing one before you create a new one anyway. If you have to create a new one, eventually, this one that you have currently will get deleted. But once your application gets deployed, you can manage them individually. So that is the perspective I'm taking it. Otherwise, if you want to make a change to one of those services, then you need to be the one that actually wrote the chart, right? If you're the one that wrote the chart, then I presume you have to repackage everything again and upload that chart again, that Helm chart again to the repo.
Yeah, so like if you are managing the Helm chart for your company, or one of the Helm charts for your company, and that chart deploys 3 different deployments, and you are only updating one of those 3 deployments, then it's only going to change out that one change deployment. It'll reapply everything, but everything will show unchanged except for the one area that you did change.
Right. Okay.
Edward says, within a single manifest, Helm 3 will replace the entire manifest. If you add an environment variable to a deployment, it will remove it on a Helm upgrade. Helm 2 only changes the differing fields. And I guess maybe that's the real question, is what's the goal here? Are we talking about, are you trying to keep something from cycling out when you do your iteration, or are you talking about trying to revert perhaps a hand edited change? So even though, like Edward points out, that Helm will replace the entire manifest, it won't restart everything. So if you're just trying to avoid some downtime from services restarting or something like that, then that should be pretty safe. It'll only restart the things that have changed. But if you're talking about something different, let us know.
Well, so one thing I'm thinking as well is, let's say you have a particular configuration that you want to apply to your Helm. Helm has a concept of values, right? It has a file called values.yaml. In that values.yaml, you specify how you want your values to be. So if you upgrade your charts and you give it that same values.yaml, the result that you put, the values you put in the values.yaml should get restored to your application as well.
Correct. Yep.
Okay, so like what I wanted to show you now is to create this deployment file, this deployment object that I have here configured. So I just simply say kubectl create -f put deployment the YAML, and then it's created. So let's do kubectl get pods. I know this will go to vote namespace, except I change it. Okay, so a lot of these pods were getting evicted. I think it was when I deployed that application earlier. Okay, let me view the file. I want to see what namespace this file is for deployment. Okay, I don't specify any namespace, so it's going to be in the default namespace. All right. So kubectl get pods, and we see the vote. 3 of them are here running. So those are the 3 replicas we wanted. So let's scale this. Let's scale it to more nodes. Okay, before we scale it, let's actually delete one because it will be easier. So we're going to see the monitoring capability of deployment objects. So let's say kubectl delete pod, and let's just delete one of these. Okay, it's deleted, but you're going to see that very soon we're going to have that pod replaced. So kubectl get pods, and we have it replaced. It's only been running for 11 seconds. So see the other two are 76 seconds each. This one is just 11 seconds. And if you check the IDs, you also see that this one, 9G, is here, which is the second one. 5W, ending in 5W, is also here. But the one ending in P5, which we deleted, is gone. There's no more P5 here. The replacement is 7.2, which is just 11 seconds. So that is exactly what deployment control objects do. They are going to monitor what is happening, and they're going to make sure that your desired state is the same as your current state. Okay. So let me also show you this. When you do kube replica set, each time you create a deployment object, which we did here, let's say kube deploy. That shows you this default deployment 3/3. But in addition, it created a replica set. So replica set is the one that actually does the scaling. Okay. So replica set is also a controller object, but deployment object is also a controller object. And you can also scale. You can scale from the deployment object. So let me show you this. This is going to show you the hierarchy of objects, how objects, in a way, in Kubernetes have hierarchies. I could scale this or I could delete this, and we can do it, but the deployment object is not going to let it do it. It's going to say, nope, I'm the one in charge here. You are not allowed to scale this object. But let's just do kube scale replica set, and the name of the replica set is this one here. And let's say minus replicas equals 6. It says scaled. Okay, let's do kube ports. See, somebody is terminating them. He created them quite okay, but someone is getting rid of them. So we're back to 3. You see, we're back to 3. But we scale it to 6, right? And they were created. But as soon as deployment objects saw that, how going to be it? I wanted 3, but now I see 6. He deleted them. So you can see that the deployment object is of a higher hierarchy to replica set. So once you manage an object with deployment, just use deployment to manage it. Don't come down to do anything with the replica set, because deployment will kick in and get rid of whatever it is that you did through the replica set object. Okay, so hopefully now helps us to understand how deployment objects, how controller objects works in Kubernetes, because that is very important for understanding operators. So essentially, operators are control loops, or they are controller objects. They are controller objects, which means they are going to continuously monitor what you're doing, and they're going to bring your desired state to effect. So how does that tie into deploying your application? Oops, I'm going up too much. So how does that scale or come to managing your applications? I told you that operators is all about automation. It's all about putting some intelligence of the operator into your application. For example, a database, so that all the repetitive stuff you do, all the repetitive stuff that the DBA does in the database, you don't have to do it anymore. Just put the automation into your operator, and your operator will help you do that. So I see them like robots. Have a robot to manage your database, MySQL, etcd server. Remember, I told you earlier, if your etcd server on your Kubernetes cluster is down, oops, I'm going far too much again. If your operator on your Kubernetes environment is gone, like this one here, if your etcd server is down, your whole cluster has lost its storage. So if you deploy this with operator, though, operator will be monitoring it, and it will also put all the knowledge about managing an etcd database into it. So it frees you. It frees the time of the of whoever is managing this cluster, not worry anymore about the etcd server. Sorry for that. not worry anymore, and operator will take over whatever you need to do, which is above Helm. Helm will deploy your application, but not necessarily watching it to see what is happening, not necessarily having some operator ideas on how to manage this application. It may not know how to scale it automatically. It may not know how to upgrade it. It may not know how to back it up. It may not know how to performance tune this etcd server. So operators are built to do that. So if you look at the definition here, operator is a controller. You can see that word here, controller, that encodes human operational knowledge. Okay, so it's answering the question, how do I run this application? How do I manage it on day 2? This application is complex. Kubernetes or containerized environments were not originally designed for stateful applications. But now that we're porting stateful applications into this platform, how do we actually ensure that our management is hands-free? And if you listen carefully to what I'm saying, if anyone has used a service like RDS, Relational Database Service on AWS, or any of the other database, managed database service, it's exactly the same thing. What does a service like RDS do? It helps you to create an instance, help you to tune it, help you to back it up, help you to scale it if you need to scale it dynamically, even without you paying attention. So that is what Operator is all about. It's about bringing managed services onto your cluster without you having to worry about them. So you can see how this is taking over the world. You can see how everybody wants to use Operator. From 2016 up to now, if you go to this website here called Operator Hub, IO, you see that there are so many operators that people are developing. This is a website created by Red Hat. So if you search for etcd operator, you're going to see etcd. You see that there's an operator there for you to use. If you search for Prometheus, these are complex applications that will normally take a lot of your effort to manage. Once they're deployed into operators, you just put a lot of automation into your environment. So you can move from, managing your applications in a traditional way to maybe using something like Helm. And like I said, operators does not remove Helm. Because what you're going to see these days is that people use Helm to deploy operators. And you saw me do that already. You saw when I do the kubectl Helm list. When I did the Helm list, you saw the operator here. Helm was used to deploy this. So you write your operator, and then you package it into a Helm chart, and then you use Helm chart to deploy. That makes your life very easy. So both of them complement each other. One is not meant to replace the other, which is what I was saying that initially when I started using them, that wasn't clear to me at all. But staying on it, now I understand clearly how both of them can work together. Again, I don't know where I am, but each time I click, it's the wrong one because I put a lot of presentations here. Okay, next time I'll make sure I separate my presentations. Okay, so you can see here, let's go through book definitions. These are taken directly from CoreOS. And by the way, Operator was developed by a company called CoreOS. And if you know, Red Hat bought CoreOS. Then IBM bought Red Hat. So Operator, you can see now is a product of IBM. But you can see the definition. An operator is an application-specific controller that extends the Kubernetes API to create, configure, and manage instances of complex stateful applications on behalf of Kubernetes user. It builds upon the basic Kubernetes resource and controller concepts, but includes domain or application-specific knowledge to automate common tasks. That is right to the point. It puts some of the knowledge of the administrator to help you do what you need to do. And here's an example of the one I'm going to show you. If you were to deploy etcd server without the operator, if you wanted to scale, you have to perform all these steps. You have to create a DNS name for the new etcd member. You have to launch the new etcd instance. And then you have to use the etcd administrative tools, like this command here, to tell the existing cluster about this new member. Instead of having to perform all these operations, if you automate that into an operator, all you have to do is kubectl scale or something of that nature, like you saw me do the other time. And then you can now have your cluster scaled. And that has taken a lot of overhead from you having to do this manually to now putting that information into an application or an operator that knows how to manage this application for you. So I hope everyone gets that point. So an operator, just to summarize, comprises of two main parts though. It has a controller path, which is, you know how a controller works. Then it has the ability for you to extend Kubernetes objects. And that is what we call the CRD. Custom resource definition was an add-on to Kubernetes that enables you to create objects and add them to Kubernetes. For example, in the Kubernetes deployment, original deployment, if you say kubectl git meetup, just an example, Kubernetes will yell at you and say, I don't understand what meetup is. The server doesn't have a resource type meetup. However, I can create a custom resource called meetup. Then once I install that custom resource, I can now say kubectl git meetup, and then the cluster will tell me, okay, this is the meetup object you have. So earlier, when I showed you the Kubernetes architecture, I told you that Kubernetes is very, very extensible. You can extend it using custom resource definitions. So an operator comprises of the controller, which is going to be monitoring your object, but those objects, you can create them using CRDs. And so from development perspective, creating an operator requires a lot of programming knowledge. I mean, you are trying to extend Kubernetes, this big API. So you need to learn to program maybe in Golang. A lot of people use Golang. Or you can use Python. Well, Python has a very few percentage of the operators. I would say, I think I saw statistics that say that up to 70% of all operators are written in Golang. So you need to be that person who understands Golang language very well to be able to extend and create Kubernetes and create your own CRDs. But that is if you're a developer. If you're not a developer, if you are an operator guy, you still benefit a lot from using the operator. You just may not be able to create them. So all the ones I showed you here, these are operators created by different companies. It could take them a lot of time to produce one of these, but once they have it produced, then of course it becomes automated. So anybody can use it, and then they can continue to enhance the development of this operator. So recently, again, Red Hat, IBM came up with something called the Operator Framework. Operator Framework. If you go to the GitHub, you see there, which is basically an SDK that will help you create your operators. Okay, so it's to make your life very, very easy compared to before. If you are a developer and you wanted to create your own operator, you can download the operator SDK, and it makes your life very, very easy. Google Cloud has another one as well. I'm not sure, maybe QBuild or something, don't remember the actual name, but I would say those are the two leading APIs or SDKs for creating your own operators. So that is it from development perspective. You need to have a good knowledge of Kubernetes, a good knowledge of programming to be able to create these CRDs, and on top of that, create a controller object to make your operator. But from users' perspective, I would say they are fantastic. That seems to be the future. If Kubernetes is the operating system of the cloud, and if Kubernetes is being used to deploy both stateless and stateful applications, as long as people would like to deploy stateful applications, then operator is going to be very, very useful going forward. And for that reason, it's becoming very, very popular. And I thought you guys should be aware of that. So let's see if any question. Otherwise, I'm going to attempt to show you how to create an operator, how to create a cluster using SCD operator. And everything I'll be doing is from a GitHub repo. I didn't create that. It's just one of the examples that CoreOS made available. So you can follow me do it, or you can do it at home if you have your own cluster. So
cool. Yeah.
Do we have some questions?
I think we're caught up on questions.
Okay, sounds good. So basically, we're going to use Helm. I already introduced Helm. We're going to use Helm to deploy our operator. And as you can see here, we actually got it deployed already. So if you do Helm, Helm list, we saw that we have the LCD operator. Let's kill it, Helm delete operator, and then let's install it again. Hopefully, we'll be able to get it back. So let me do a history to see, grab etcd etcd operator so that I can use the one I have there before. So I can install it with this one. I can just do 1688, and that will help me deploy that. Okay, so let's wait for just a few minutes. Helm will install our operator, and you can see how both of them are being used together. Okay, cool, it's ready. So kubectl get, let's do Helm list first. Helm list, now we see it listed back there. And now if you say kubectl get pods, kubectl get pods, which you see pods related to the operator, all of them are up and running. You can see all of them are up and running. So now we have the operator installed. Now if you do kubectl get CRD, the custom resource definitions, you see we have a lot of them. Some we can see them from, let's go and grab SCD. You can see them here. SCD cluster, SCD restore, SCD backup. So then if you say kubectl get etcd backups, that backups, so you have an SCD backup there, okay? I created some of this before, and so in doing the demo, delete them and do them again, or some things may work, or they may not work. But if you follow the GitHub, everything should work. So what I'm showing you here is that if I did not deploy the Kubernetes etcd operator, and I run that command just like I did with get meetup earlier, and it yelled at me, it's going to do the same thing. But because we just deployed the controller, the operator is now able to give me that. Okay, so let's create a cluster. And again, like I said, we can just follow through the instructions to get all this done. So I'm going to go to where I have it. So that is my etcd operator. Now, all the examples we're going to use, you can clone the repo. Just clone the repo, and then you have everything I have in there. So here's the repo, and just simply come here, clone this repository. I already did that, so that is why I have all this directory here. All the examples we're going to do will be here under the example directory, okay, to create a cluster. So to create a cluster, we're just going to do kubectl create -f, and we're going to create this cluster here. If it's not there already, okay, it said it's there, so I could delete it and create it again, like I was saying. Kubectl delete -f. Okay, it's deleted. So now I can create it again. Sometimes when you delete resources, give it a few times for everything to clear up. Then you can do kubectl create, and that should help you create your cluster. Okay. So we got that created. Let's go here. All the examples we're going to do, like I said, are going to be here. So you create your cluster, you have it there. If you don't have knowledge of Kubernetes, you'll still not be able to do it. But if you do, then you'll be able to do that, run them. So now that we created that, ideally, you should now be able to go in there. If you want to delete it, you can also delete it. Okay. So actually, let me mention something here. If you, in our own case, we deploy etcd using Helm. So we don't need to create this file. Okay, I remember this file wasn't working, but when I created my operator using Helm, then it was fine. So I can delete this. It's not useful. I don't need it. So let's delete that. We should still be able to do the labs. So just remember that it's better to create your pods using Helm rather than creating using that file that you are given there. So resize. The resize is simply like what I did before, nothing different. So if you do kubectl get pods, we have all of them running here. So if you want to change that, if you say kubectl get deploy, when you check your deploy, you have all these ones, each one of these here are running. Okay? So we want to scale it. We want to scale it to more nodes. So let's use this example. Let's use the example for the deployment. Since we don't use that file though, we didn't use the file to create it. So if we scale that, that may not going to work correctly. So let me see how we can scale it since we did it with Helm. Kubectl pods. We have those three running here. Operator this, operator that. So we need to find the right kubectl get deploy. So we have that there. Let's get kubectl get replica set. All of them are there. Okay. So let's see this file and see kubectl in deployment by YAML. Okay, let me just run that command again and see. And then we can scale it from there. Let's kubectl delete, create. Okay, kubectl get pods. Okay, so this is the one that is getting created. Let's wait for this to wait for them to finish. Usually take time. Wait for this one to finish. Then if it has another one to create, it will start doing the other one on and on and on. And you can describe it. Kubectl describe pod to see what is going on. Yeah, it's going well. No problem so far. So let's wait for it. The first one is actually done. First one is ready. It's starting the second one. There are going to be about 3 of them. So after that, the second one will start creating. Then after that, the third one, because we wanted 3. If you look at this file here, example cluster, this says 3 copies. Set 3 copies. So while we're going through that, you can see that when I show you the pod object earlier, I told you that YAML files follow a kind of similar syntax. So the API version for this controller for this SCD operator is this one here. And now we're creating an SCD cluster. Instead of putting a pod or a replica set or a deployment, now it's SCD cluster because they have created a CRD, a custom resource definition object called SCD cluster. And now in the metadata, this is the example of the cluster we're creating, and we want 3 copies. And we want this version. So this has simplified a lot of things I would have otherwise do. So if you do kubectl get pods, now the second one is ready and the third one is coming up. So once the third one finishes, then I can scale it for you to see. So we can scale it. Then after that, we can upgrade it. And we can do a whole lot of stuff with that, which makes your life easy. So let's watch for that. Kubectl get pods. Okay, so wow, one of them got evicted. These 2 are ready, but it looks like the other one got evicted. So these are the ones we're looking at. Oops. These are the ones we're looking at. So we wait for it to finish, and then we try to scale it. While it's doing that, if anybody wants to keep the discussion going, feel free to do that. But basically, we're seeing how an operator is deployed. There are a lot of them. The one I deleted earlier, the Prometheus, is also an operator. And all I did was run the command, and then it got deployed. Helm install Kubernetes operator. You can use Helm to search. You can use Helm to, I think, Helm search repo. And then you can put something like Prometheus. Excuse me. And that's showing you anything that has to do with Prometheus. Just like you will search with your YAML or apt to search for any application, you can also do the same thing here. And then if you want to install it, just do Helm install, and then tell it the operator you want to install. So let's go back to see what is going on. Okay, 3 of them are running, I think. So these are all the pods. So now we have an LCD cluster of 3 nodes. To scale it, you don't have to go through all the process that I enumerated here earlier. Again, let me hope I click on the right slide. Let me just present before I switch over. Okay, so now if we want to scale, we don't have to do all this stuff. All I'm just going to do is scale it. Kubectl, let's say get deployed to know what we're going to scale. Okay, so let's edit that file, kubectl vim lcd cluster vim, okay, example lcd cluster.yaml. So let's just change this to, actually let's do it a better way. Kubectl edit. Sorry, let's change this to 5.
So again, that object was etcd cluster, which is a custom object using the custom operator. And that operator understands this is more than an API. This is more than just pop in a new one or pop in 2 more. We have to actually gradually bring one in, have it replicate all the data. Once it's replicated, it has to be marked healthy and accepting reads and writes, and then we can move on and bring in the next one, because we don't want to upset quorum. So with etcd, if we were to go from 3 to 7, then our 3 would be inquarate because it's not enough to maintain quorum. So you want to stair step that every single time, and that's the human knowledge that an operator brings to the table. So it's almost like the operator is your etcd database administrator, and instead of having to have a human there knowing that and doing that and working it through the steps repeatedly, we can just have the operator running a control loop doing it, and have all that intelligence built in.
Yep. So now I made changes. I want my new replicas to be 5, and kubectl has a command called apply. So I'm just going to apply it now. Kubectl apply. Oh, that should be double P. Okay, so it said it's been applied. So if I check my parts, kubectl get parts, I should see additional ones being created. Just wait a few minutes, and you see another one will start popping up. Currently, we have 3 of them. And let's see, has another one started? One is gone into pending. Okay, that is actually a 4th one. You see there are 4 now. They are all 4 now. So the new one is gone into pending, but it might start initiating very soon. It's still pending. So if you do kubectl edit pod and copy that one there, it will tell you what is going on. Got to describe. Okay, it had some issues, but it looks like it's doing it now. Yep, it's doing it now. So we wait. We have 4. Very soon the 5th one will get created, and that is how you scale it. So you see, it makes your life very easy in terms of how you are doing this. And once that finishes, we can also delete one of them, and we can see how the etcd operator kicks in to make sure that another instance of etcd is running. And then after that, we can even do backups. We can issue just one command to make it back up to AWS. We can issue just one command to make it restore. At the moment, it only backs up to AWS S3. So you need to have an S3 account. You need to configure your secret key and secret access key on your master node to make it do that automatically on your behalf. So now you have 1, 2, 3, 4, 5. We actually have 5 of them running now, except that this one is not fully ready yet. But yeah, all of them are ready now. Okay, so we see how we scale it. Our etcd node, which otherwise, if you had managed this without an operator, you see how involving it is. And just to mention, a lot of the applications that you use operator to manage are inherently complex. And I can say that because Prometheus, I've tried to deploy Prometheus before without an operator, and I know how much time it took me compared to when I now had the operator and I just need to run, Helm, install Prometheus operator, and I just wait a few minutes and then it get deployed. And fully configured, fully ready to be consumed, and fully managed, like I said with RDS. Okay, so let's delete one of these. You've seen this already, but just to do it again, got to delete pod. One of these, any of these will do. And we'll say that that is going to get replaced immediately. A way to always see this is to have another terminal so that you can be watching your pods. So we currently have 4, but we're going to see the 5th one get deployed because they have to be 5, not 4. Okay, so after that, we'll do one more, and then hopefully the concept of an operator should be clear to you guys, and you can give it a go. If you have a cluster at home, if you don't have a cluster at home, clusters are easy to deploy, either on the cloud platform or on your laptop. You can either use something called Minikube or Docker for desktop. If you have Windows or Mac, you can use Docker for desktop. Just install it and enable Kubernetes. First install Docker, then enable Kubernetes. But if you have an AWS account or GCP or whatever, you can go there and create a cloud Kubernetes cluster using a tool called KubeADM. You can use KubeADM, you can use kops. Any of those makes your life very easy. And I have blogs on those. If you want any instructions on any of those, just send me an email or go to the blog I wrote on those. So you can see we have 5 of them back. And the youngest is just 47 seconds, while the others are this old. Okay, so that is one way you can keep doing that. Let's see what else we can do. We've simulated failover, and we've seen that how it works. Failover is when you delete one of those. Okay.
And I'll point out to the audience, we have about 10 minutes left. So you want to, if there are any questions that you've been thinking of, holding back, asking, now's the time.
Yeah, let's upgrade. See how easy it's going to be to upgrade. So currently we're having a version 3.1.10. So we're having version 3.1.10. That is what we specify. But if you want to see that, just do kubectl describe pod, and then copy one of these, and you see that we're having version 3.1.10. Kubectl describe pod, kubectl describe pod. If you come here, you see the version that we're running. successfully put image. So this is the version we're running at the moment, 3.2.13. So I have another YAML file here that will upgrade. So let's do this file. So now we're going to upgrade to 3.4.9. Imagine upgrading your database live. This is what we're going to do. In reality, it's scary, but not with operator. So let's do kubectl create -f, or let's just apply. I think it's better to apply. Kubectl apply -f, upgrade. Okay, it's configured. So let's check, see what is happening. Kubectl get pods. Now we're going to see pods being replaced one by one. Now, Kubernetes has a concept of rolling update. Rolling update. In a rolling update, when you try to upgrade your application live, rolling update will start going through the pods. It will start with one, kill it. Then while it's doing that, you still have 4 other ones running. In our own case, we have 5 replicas. So when it start to upgrade one, the other ones will be responding to customer. Then once it finishes with one, it will move to the next one, on and on until it finishes. In that way, there's no downtime. So that's the advantage of this kind of a live upgrade. There's just no downtime. You are just responding to customers as they need be. So you see that it's going to start replacing them. And once it's done, we can describe them, and you see that it has a new image, which you just give it. So this is a lot of this is more of the capabilities that Kubernetes provides, coupled with the fact that you can extend those resources with CRDs. Okay, so that will be the last demo I will do. If you want to do and follow up the rest of the exercises, you can set it up. I will send you you will see the GitHub repo. You see it on the slide deck when I send it.
And I popped it up in the video as well. So,
okay.
So we had a couple of closing comments here. Operator Hub looks, oh, this is from Edward Mao. Operator Hub looks great, much better than just searching Google and hoping for the best. And yeah, I completely agree. I think having a central location for finding operators is useful. And then also, looking to see who provided the operator. I think that's, sort of the second thing that I look at. Like if I was looking for an Elasticsearch operator and I found that it was provided by Elastic, bingo, that's going to be the one that I use. David Brady said, thanks for the great presentation. So well done, Damian.
Thank you.
And then Jithus, I don't know how to say your name. If you really want to learn how the various building blocks of K8s works, try doing the K8s installation the hard way. And yeah, Kubernetes the hard way is awesome from a learning perspective for sure. Like you said, it's not something I would recommend doing for repeatable production level Kubernetes work. So it's good to learn all the parts and pieces. It's like building your own car. But if you want something that is repeatable, has a warranty, and has predictable performance, then ultimately you probably want to go with one of the standard installations.
Yeah, definitely. Just to add, so if you were to go for, if you wanted to take the exam, the CKA, Certified Kubernetes Administrator, then it makes sense, a lot of sense for you to go ahead and deploy Kubernetes manually. In fact, it's recommended. And I definitely did that when I took my exam, and it helped me a lot. But, that is not applicable in production environment, not even to a tiny bit, because majorly, even though people could deploy their own Kubernetes clusters on AWS or on-prem, I would say that more than 70% of people still prefer managed services like OpenShift or EKS or Kubernetes, Google Kubernetes Engine, just because managing a Kubernetes cluster on a day-to-day basis may not be that easy. And when people are moving towards automation, you probably don't want to involve your time in this kind of day-to-day operations, like So yeah, definitely just agree with Brent. You probably don't want to do that for production, but for learning purposes, fantastic.
Absolutely. All right. Well, thank you guys. We had a lot of thanks in the chat. I popped them all up on the screen as well. Thanks everyone for attending this month's meetup, and we're going to do this again next month. And watch your email for the topics. And also, like Damian was asking, if you have any ideas for topics that you want to hear more about, feel free to message us in the meetup app. And that's a good way to reach us and tell us what you're interested in finding out more about, and then we'll see if we can either find someone to present or work up the material ourselves and present it ourselves.
Yeah,
so
sure. And again, if you want to present, the floor is yours. This is your meetup. Feel free to come and share your ideas with your friends and colleagues.
Absolutely. So this video, if you want to go back and rewatch it, it's going to be at the same link. It should stay available for the foreseeable future. I'm also going to download the recording and pass it off to Damian. And I know that, or I think anyway, that he uploads them to his YouTube account as well. So it'll be there as well. And otherwise, we'll see you guys next month. And thanks for attending.
Thank you, guys. Bye.
Thank you.